What's going on, smart people? I'm bringing you another coding video today, and I almost made two, but I realized I couldn't really justify splitting this into two videos, so I'm bringing them into one. So today I'm going to show you how to do two things. One is make a heat plot in Python, because I was searching everywhere for a good way to learn how to make heat plots, and the online resources just seemed god-awful, and here's why. It seemed like it was tailored towards people who were importing a whole bunch of data that was already organized in terms of like columns and rows, and they were doing this complicated stuff with like data frames, doing transposes on these, these multi-dimensional arrays, and I was like, there has to be an easier way to do it. Figured out an easier way, and I'm going to show you it today. The whole point with the heat plots is, say you have some function z that is a function of like x and y, so you have this two-dimensional surface inside of some three-dimensional coordinate system. Well, with heat plots, you can replace one of those dimensions with a color, and some gradient of that color can be a better visual way of interpreting data. So one thing, more than anything, is, it depends on who you're showing this data to. Maybe some people can appreciate a three-dimensional plot, maybe some people can appreciate a color gradient more. So it's more options. That's never a bad thing. And sometimes these functions that you're working with have some constants that they also depend on, that you might have as an input, like, by the way, c is equal to 5, and then you see how that affects the graph. Well, what happens if c is equal to 6? It's something that's constant for all of those x and y terms. But what I'm going to show you how to do is be able to sweep over those constant values and have the graph continuously updating. That way you can see how the qualitative behavior changes. So that's the second thing that we're going to do. But I've talked enough. I think it's time to get started. So getting started, I'm going to be using Jupyter Notebook in Python, or Python in Jupyter Notebook, whatever. And as you can see, I've already imported the necessary libraries that I'm going to be using. So while you guys copy this down, I'm going to go ahead and explain what all of this is for. Matplotlib inline, that's just saying that I don't want any pop-up graphs in another window. I want it all to be in the Jupyter Notebook. Import NumPy, we're going to be using arrays, and Python has no native arrays. Matplotlib .pyplot, well, that's pretty self-explanatory. We're going to be doing some graphing today. widgets, that's going to give us this little widget bar that we can move so that we can fine-tune certain parameters. Seaborn, that's going to give us access to the heat map function. I always say heat plot, but let's get started. So we're going to be defining some functions, some multi-dimensional function that we're going to want to plot out, and we're going to want to be able to like tune certain parameters. So we need to discretize the space. We need to form a grid of x, y numbers, because we don't just want 1, 1, 2, 2, 3, 3. We're going to want 1, 0, 1, 3. We're going to want to be able to evaluate this at all of these different x, y values. So that's why we need to make a grid. But let's go ahead and define what these x, y values are. So let's say x is equal to np.linspace. Let's just go from 0 to 10 and 10 points. And we'll do y similarly. So y is equal to np.linspace. Let's just have the same thing, 0 to 10 and 10 points. You know what, let's make this, let's add one more. Let's just make it 100 points, because we're going to want this to be pretty smooth. Okay, and the next step is actually making a grid out of this. So right now we have two NumPy arrays. Now we need to make some multi-dimensional array out of this stuff. And the way that we do that is with another NumPy library or another NumPy function. So we're going to say x, y is equal, so that we're changing the definition of them, is equal to np.meshGrid. This is the important part, x, y. Okay. So now we have a whole grid of x, y values. Now we need a function to feed them into. So I like to define this separately from my plotting function that we're going to end up establishing. So let's define some function that is a function of, let's keep it general. Let's say a and b. And we're going to return, let's say np.sine of np. The square root of a squared plus b squared. Okay, so we have the sine of the square root of a squared plus b squared. Okay, great. And so next what I want to do is I want to define some like what would normally be my z values, right? We're adding height to our surface. So z, we're going to say z is equal to f evaluated at our x and y values, at our mesh grid. And then the next step is we need to be able to plot the stuff out in our little heat map. So we can say AX is equal to SB dot heatmap Z. So this is the very bare bones version of what we want to do here. So let's go ahead and run this just to see, if we just do, this is barely any lines of code at all. Let's see what this looks like. So we run this. That looks pretty cool, right? We get our little sine of x squared plus y squared. There's some weird stuff going on to where as y goes up, y is actually decreasing. I don't like that. I like my y-axis to be increasing if you go up. So I'm going to say ax dot invert underscore y-axis. And when we do that, now it's switched. So I like that much better. Cool. Now this is where, so now this is pretty much all there is to making a heat plot. It's pretty self-explanatory. It's not too hard to make. But now let's make this a little bit prettier, and let's make it more general. Let's make it more apply to more stuff. So let's introduce some other tweakable parameters. And what I want to be able to do is be able to sweep over those parameters. So I'm going to take all of this stuff here and put it in its own function. So I'm going to define some new function, define some plotting function. The whole idea is that we're going to be able to sweep over some parameters. So let's go ahead and introduce those parameters right now in our original function. So let's have one thing that's inside the entire argument, affecting sort of like the frequency, and then let's have something outside that affects, say, the amplitude. So let's make this one a D, and let's make this one, I guess, a C times. Let's say that it depends now on C and D. Great. And these are going to be, those C and D's are going to be the thing that we're going to be able to toggle. Okay, so plotting. So this now depends on some parameters C and D. And now let's put this stuff in here. Let's go ahead and indent this. I don't know why it didn't do that. Okay. Now, so right now we're defining our z value as our function evaluated at x and y, but now we have our two other parameters, c and d, that we're going to want to sweep over. And we can initialize these too if we want, so we can, for example, let c equal 1 and d equal 1. That way they're not really doing anything right off the bat. Okay, and what else do I want to do? Well, this part right here, this color bar, what it's doing is it's sort of telling us like the amplitude of this multi-dimensional like trig wave, right? So if D isn't 1, then this is going to change, right? It's not going to be normalized to 1. And that's going to be constantly fluctuating. You know what? I'm going to leave it like it is for now. Just know that we're going to be implementing some stuff that's going to fix this, keep it constant. Okay, so let's just see how this affects it. So we got that. Down here is where we're going to have to specify that this stuff is going to be interactive. So we can say interactive plot is equal to our interactive function that we imported. Interactive. Okay, and the first argument is going to be the function that we're plotting, or that we're going to be interested in calling. So this is just going to be plotting. Okay, and then the next arguments are going to be the things that we're going to be sweeping over. So our C's and D's, and we have to give it a range that we're sweeping over. So C is equal, what's a good value for this? Let's just go from, 0 to 10, and let's increment this by 1. And then the next one is D is equal to, let's let D start at 1 and go to 5. Because if D is 0, well then that's going to have an amplitude of 0. That's not going to be very interesting. Okay. And let's increment this by 1. Perfect. Then what else? I think that's all. Then we just need to call this function, interactive plot. Let's go ahead and run this. Okay, so right here, this is what I'm talking about, how we have our little sliders. And if we move them, we see that the graph is constantly updating. That's pretty cool, right? Now this is where it'll be nice to be able to fix this color bar here. And the reason for that is because this D out here, that's controlling the amplitude, right? So if we adjust this, we're not going to see any qualitative difference in the graph, the way that it looks, and that's because the adjustment is happening in the color bar. But if we impose limits on that, if we give that an absolute scale, then it's going to compensate by changing the graph a little bit. So for example, if we go over to, so since we're letting D go all the way up to 5, that means it's going to hit at highest amplitude of 5. So let's go ahead and let's go ahead and set our limit there. So we can say Vmin is equal to -5 and Vmax is equal to -5. And then if we run this again, now it's going to show a bunch of different behavior here. What's going on here? Oh, okay. I was being an idiot. I said the max is the min is the -5 and the max is -5. We want that to be a +5. There we go. It's still going to change, yeah. So here we see that if we adjust the amplitude, it changes the graph now, not the color bar. Okay. So I think that's a pretty useful thing to know how to do. What else can we do here? It's kind of cluttered on these axes. So one thing that you can also do is you can sort of skip certain ticks, and the way that you do that is you say x tick labels is equal to, and if you put it as an integer, it means it's going to skip that many integers before talking about the next one. So if we say 10 and do the same thing for y tick labels, that's much cleaner. Okay, and you can still do the other stuff. We're using AX, but we can still do stuff like, we can still use the PLT function, plt.title, you know, just my title, and it'll incorporate it onto there. Cool. So this is just, I think that this is such an easy way of using a heat map that I think if you Google how to use it in Python, it's a little bit overwhelming, and I don't think it's very helpful, but maybe I was just looking in the wrong places. You can also do other stuff like change the color of the heat map, and there's a whole library full of different colors that you can use. And the way that you change it is by saying CMap, and then you say, you have to know what the names of the colors already are. So one, for example, is cool, warm. So that's the gradient, cooler colors to warmer colors. Invalid syntax, did I forget? I forgot a comma. And then we get like blues and reds, which are, I kind of prefer the other one, to be honest. I think another one might be rainbow. Rainbow. Yeah. So you could spend all day adding a whole bunch of bells and whistles to this, and the whole thing about making videos like this is that people always comment in the comment section things that you can add, like, you can also do this. So if you're watching this video learning how to do things like add widgets to plots or how to make heat plots, I would also recommend checking out the comment section, because I'm sure people will be, saying, Andrew, you forgot that you can also do this. So keep that in mind. But it's just a short little video, actually not so short. I see that this is almost 12 minutes long. But I hope you guys found this video helpful or a little bit useful. Let me know in the comment section if you did, and I'll see you guys there.